All right, guys. So in this video, we are going to talk about dividing polynomials. Now, if you did not finish the practice from yesterday, feel free to use the first part of class to work a little bit more on that practice, because this material probably will not take as long, so we're not going to be doing any graphing with it, but I'm going to show it to you, and it's going to seem a little weird, but it will be an introduction into kind of the rest of this unit. So dividing polynomials, one of the reasons why we need to be able to do this is because sometimes there are things that don't look like they can be factored, but they can be factored using something called polynomial division. And there's a couple different ways to do polynomial division. The one that we will focus on the most is synthetic division, but I will talk some about long division here at the very beginning. So to kind of illustrate this idea, what I want us to talk about first is, what do I get if I do 5x plus 3 times x minus 2? Okay. And I know how to do this by foiling. Okay, so if I foiled this out, here's what I would get. First, 5x times x is 5x squared. Okay, outside, that'd be 5x times negative 2. That's negative 10x. Inside, 3 times x. That's plus 3x. And then last would be 3 times negative 2, which is a minus 6. Okay? Altogether, this becomes 5x squared. Combine those two inside terms, this would be minus 7x minus 6. Okay, so I feel pretty confident about that. So I know that if I were to multiply those two things together, here's what I would get. Okay, now with that in mind, and here's kind of the big idea of today, what if this is true, what would I get if I did 5x squared minus 7x minus 6 divided by x minus 2. Okay. Well, if I just look at what I did up at this previous step, if this times this is this, then what that means is this divided by this should be whatever I get here. Okay. This works very consistently when it comes to numbers. So I'm expecting that when I'm done with this, I should get 5x minus 3. This works with numbers. So like, for example, if I told you that 4 times 2 equals 8, and then I asked you what's 8 divided by 4, well, if I just took both sides of this equation and divided by 4, okay, 8 divided by 4 should give me 2. Okay, and the same thing works here with polynomials. And so what I'm going to do here is I'm going to show that this is the case and that I do actually get this answer, and I'm going to use something called long division to make that happen. Sorry about that. Okay, so this is called polynomial long division. I'm not going to ask you any questions about this on an assessment because this process can get a little bit long and tedious, but I'm going to show you this here so that I can go back to this example a little bit later and show you how this relates to synthetic division. And so let's go ahead and set this up. So the first thing that I'm going to do, just like with normal long division, is I'm going to put this thing that I'm dividing by, or that I'm dividing, underneath this bar right here. I typically call this the house. Okay. And then on the outside of it, I'm going to put what I'm dividing by, which is x minus 2. Okay. Vocabulary wise, this thing underneath here, and this is called the dividend. And then this thing on the outside is called the divisor. Okay. All right, so first things first, what I'm going to do, and I'm going to kind of go side by side on out here. What if I just think about normal long division, because a lot of you guys have probably not done any normal long division since you were in probably, I don't know, 5th or 6th grade. Let's say that I was going to take 88 and divide it by 5. Well, the first thing that I do is I try to see how many times does 5 go into 8. Well, 5 goes into 8 one time. Okay, and so what I do is I write a 1 up here on the top for my answer. Well, I'm going to do the literal exact same thing here. I'm going to ask how many times does x go into 5x squared? Or in other words, what do I have to multiply x by to get 5x squared? And the answer to that would be 5x. Okay, so I'm going to go ahead and put a 5x right here. Now, back to normal long division. Once I put this 1 up on top right here, what I do then is I take 1 and I multiply by 5, and I get 5, and then I take the 8 and the 5 and I subtract them and I get 3. Okay. Well, again, just to illustrate this, I'm going to do the exact same thing right here. I'm going to take 5x and I'm going to multiply it by my divisor out here on the outside of this house. So 5x times x is 5x squared. And then 5x times negative 2 is negative 10x. Okay. And then just like in normal long division, what I'm going to do is I'm going to take these two things and I'm going to subtract them. Now, this is very, very important. I'm going to put parentheses around this because we have to remember to distribute this negative sign. So let's go ahead and try this here. 5x squared minus 5x squared. These should always cancel out when you do your long division. Okay. Negative 7x minus negative 10x. Let me write that down off to the side right here so you guys can see this. This is the only time I'll write this. But negative 7x minus negative 10x, this turns into plus. Okay, so this becomes a 3x. So when I do this minus this becomes a positive 3x. Okay, so I'm just kind of following along with steps of normal long division. I distributed it and then I subtracted. Okay, now you guys know from normal long division, the next thing that we do is we take this number and we bring it down. So I'm going to do the same thing right here. I'm going to bring down this minus 6. Okay, and then in regular long division, so I'll go back to over here, I just start this process over again. So I say, okay, now 5 goes into 38. How many times? Well, the answer to that would be 7. 5 times 7 is 35, so I distribute this here, put a 35, and then I subtract. Okay, so basically I'm just repeating the process over again. Okay, well, I'm going to do the exact same thing over here when I'm dividing these polynomials. So next up, what I'm going to do is I'm going to say, all right, what do I have to multiply x by to get 3x? Okay, well, the answer to this would be I have to multiply by a positive 3. Okay, so just like over here, I'm figuring out, okay, 5 times what, or how many times does 5 go into 38? Over here, I'm saying, okay, x times what gives me 3x minus 6, and then I'm going to distribute again. So I'm going to do 3 times x, that's 3x, and I'm going to do 3 times negative 2, that's negative 6. Okay, and to finish out, I'm going to take these two things and I am going to subtract them. Okay, remember I put parentheses around this, 3x minus 3x, that's 0. And negative 6 minus negative 6, well, that becomes a plus 6, and negative 6 plus 6 is 0. So my remainder when I'm done here is 0, okay? Which means my final answer to this is just 5x plus 3, okay? Now this differs over here with regular long division. In this case, once this number is larger than this, I'm finished, and this number right here is my remainder, okay? On this problem right here, we had a remainder of 0. Over here, I had a remainder of 3. And so if you think about how you would write this answer, you would say, okay, my answer is 17 with a remainder of 3. And what that means is my answer is 17, and I take the remainder and I divide it by the divisor out here on the front, which is 5. So over here, my answer is 17 and 3/5. Over here, my answer is just 5x plus 3. Okay. Now, a couple things that we can say about this. One thing that I would want you guys to note right here is on this one, we would say because there's a remainder, 5 is not a factor of 88. Okay, because it doesn't divide evenly. Okay, it does not divide evenly. Okay, there's a remainder when I'm done. However, on this one, what we could say, since there's a remainder of 0, we could say that 5x plus 3 is a factor of whatever we just divided by, which in this case is 5x squared minus 7x minus 6. Okay, and in fact, hopefully you guys are tracking with me here, not only is 5x plus 3 a factor of this, but also the thing that we divided by, x minus 2, is a factor of this. Okay, and the reason how I know that these are factors is because when divided, I got a remainder of 0. Okay, this is a big thing that we're going to be looking for over the next few days is, do I get a remainder of 0 when I do my division? And I do. Okay, so if you kind of want to think about this a little bit more, let's think about a number like 24. Okay, what are all the factors of 24? Well, anything that divides evenly into 24 is a factor of 24. So numbers like, let's see, 1, 2, 3, 4, 6, 8, 12, and 24 are all factors of 24 since they all divide evenly into 24. So in other words, if I was to take 24 and divide by any of these, let's say I divided 24 by 12, I get 2, and there's no remainder right there, okay? And also, if you think about the flip side of this, if I took 24 and divided by 2, I get 12, okay? So these numbers work interchangeably. If this divides evenly, then so does this number. And all these things are factors when I am finished, okay? So we'll be looking for remainders of 0 today. I'll show you in just a moment how I'm going to write it if, for example, I do not get a remainder of 0. But this is my process of dividing polynomials, okay? Let me do another quick example here, just to show you some long division, or one more example of long division. Let's say that I was going to take 6x to the fourth minus 5x cubed plus 3x plus 5. And sorry, let's do plus 3x minus 5. And let's divide this by, let's go 3x squared plus 2x. Okay, all right, well, one thing I want you guys to notice on this one: 4, 3, 1, nothing. Okay, and this goes 2, 1, nothing, plus 0. All right, if you are in a situation where this is the case, you must put in a placeholder for the missing power. Okay, so here's what I mean. As I do this, when I set up what goes underneath the house, my dividend, which is this thing here, we're going to put 6x to the fourth minus 5x cubed. I'm going to put a plus 0x squared because there is no x squared in here when I'm done. And then I'm going to put a plus 3x and a minus 5. And then on the outside here, I'm going to write down 3x squared plus 2x, but I'm going to put a placeholder for the 0. So what I want you guys to notice here is if we skip something, we must put a 0 times whatever that thing is that we're skipping in as a placeholder for that. This is going to help me keep my synthetic division lined up really, really nicely as I go. All right, let's try this here. So 3x squared times what gives me 6x to the fourth? Well, 3 times 2 gives me 6. X squared times x squared gives me 6x to the fourth. And let's distribute, okay? And I will try to do my best here to keep these colors nice and clean. So 2x squared times 3x squared is 6x to the fourth. 2x squared times 2x is a plus 4x cubed. And then 0 times 2x squared, well, I'm going to do 0 times 2, and then I'm going to keep the x squared, because what I'd like to do is I want to keep my x to the fourth, my x cubes, and my x squareds all lined up. And let's go ahead and subtract these here. And let's see what happens, and then we'll just repeat the process. So 6x to the fourth minus 6x to the fourth, those go away. Negative 5 minus 4 is a negative 9x cubed. And then 0 minus 0, well, we'll just say that's a plus 0x squared. Okay, and then we're going to bring everything else down. So I'll bring down this plus 3x minus 5. Okay, and then we're just going to repeat this process. So 3x squared times what gives me negative 9x cubed? Well, that would be a minus 3, and then x squared times x gives me x cubed. And then once again, we'll distribute. So negative 3x times 3x squared is a negative 9x cubed, so that's good. Negative 3x times positive 2x is a minus 6x squared. Check it out. I got my x squared lined up. That's why I have that placeholder in there. And then negative 3x times 0. Well, 0 times negative 3 is a 0. And then I'm going to keep the x so that I can keep my x terms lined up. And then I'll go ahead and I will subtract here. Okay, negative 9x cubed minus negative 9x cubed, that turns into a plus. Those cancel out. Okay, 0x squared minus negative 6x squared, that turns into a plus. So this is going to be 6x squared. 3x minus 0x is a plus 3x. And then I'm going to bring down my minus 5. And I'm just going to keep repeating this process. Okay, so now I'm going to ask myself 3x squared times what gives me 6x squared? That would be a plus 2. So 2 times 3x squared is 6x squared. Okay. 2 times 2x is a plus 4x. And 2 times 0 is a plus 0. And once again, I will subtract. Okay. These cancel out. 6x squared minus 6x squared. 3x minus 4x is negative x. And negative 5 minus 0 is negative 5. Now, here's how you know when you're done. When the power out at the front here is higher than the power here, then I am finished. Okay. So what I'll notice on this one is there is not a remainder of 0. So therefore, if I ask the question, is 3x squared plus 2x a factor of 6x to the fourth minus 5x cubed plus 3x minus 5, we would have to say no because we did not get a remainder of 0. But that doesn't mean that we can't write our answer. So let's think about how we would write our answer here. Well, we take this number here, this expression here, that's going to be part of my answer. And then what we're going to do is we're going to add on the remainder divided by my divisor. So in that case, or in this case, it's going to be 3x squared plus 2x. Okay, this is my answer to this division problem here. You'll notice this is the exact same as what you would do here if we got a remainder. We write down this number, so 17, and then my remainder, 3, divided by my divisor, which is 5. Okay, so it's the same thing happening here. We do our answer, okay, plus our remainder divided by our divisor. All right, so that's polynomial long division. Now, the second half of these notes here, and I'm not going to ask you to try a ton of long division on your own because it doesn't matter as much for our graphing as we go a little bit later into further into this unit. What I'm going to talk about next here is something called synthetic division. Okay, synthetic division is a really, really fast way to divide polynomials. Okay, so this is definitely a shortcut, but it can only be used in certain situations. Okay, sorry, my handwriting's a little sloppy right here. In certain situations. Okay, so in order to use synthetic division, there's two things that need to happen. First of all, the divisor, or the thing we're dividing by, must be linear. Divisor must be linear, and the divisor, or the thing we're dividing by, must have a leading coefficient of 1. Okay. So if something is linear, what that means is the highest power is 1. Okay. And if the leading coefficient is 1, it means there can't be anything outside of in front of the x. So in other words, if, for example, your divisor had an x squared or an x to the fifth or an x cubed or anything other than just an x, we can't use synthetic division. Okay. Also, in order for something to have a leading coefficient of 1, there can't be anything in front of the x. So that would be something like maybe x plus 5. You could use synthetic division. If it was an x minus 3, we could use synthetic division. If it was an x plus 4, we could use synthetic division. However, if it was a 2x plus 1, we can't use synthetic division as is because there's a 2 out at the front. Okay. All right, so hopefully that makes sense. So as long as we're dividing by something that is linear and has a leading coefficient of 1, we can use synthetic division. So let me show you how this process works. It's very, very quick. I'm going to show you a couple of examples here, and then I will put a few for you guys to practice in the OneNote. All right, so let's say that I wanted to try 5x squared minus 7x minus 6. And I wanted to divide this by x minus 2. All right, some of you guys might look at that and say, that looks a little bit familiar. Did I already do this earlier? Yes, I did. Okay, this is the literal exact same example that I started out class with here. And we did this by long division, and we know that the answer to this should be, so I'm going to write this down here. The answer to this should be 5x plus 3, okay, because we did this earlier with long division, and that's what we got. We talked about multiplying x minus 2 and 5x plus 3, and this is what we got. So we said, hey, if you did this in reverse and divided, then we should get 5x plus 3, and then we showed that was long division, okay? So we're going to do this with synthetic division, and we're going to make sure, do I get the same answer? Now, first question would be, can I use long division? Is this linear? Is the highest power 1? Yes. Is the leading coefficient 1? Yes, because there's an invisible 1 in front of x. So synthetic division is good to go here. I'm allowed to use synthetic division. So here's how synthetic division works. The first thing that I'm going to do is I'm going to draw a little box like this. And I'm going to think about what would I get if I set this equal to 0 and solve for x. If I set x minus 2 equal to 0 and solve for x, I would get 2. Okay, so what I'm doing in this box essentially is I'm taking the sign on this number and I'm flipping it. Okay, so in this case, I get a 2. And then across the top, I'm going to line up these coefficients 5, -7, and -6. Okay, 5, -7, and -6. Okay, and then I'm going to put a bar underneath because I'm going to do some, put my answer underneath that bar. So here's the process of synthetic division. First things first, I take this number and I drop it down to the bottom immediately. Okay, so if that number is a 10, I put a 10 there. If that number is a -3, I put a -3. In this case, that number is a 5. I drop it down and I put a 5. All right. What I do next is I take this number and I multiply it by the number in the box. So 5 times 2 is 10, and I'm going to write that 10 right here. Okay. All right. In the middle on synthetic division, I add. Okay, so I'm going to take these two numbers and I'm going to add them together. That's different than long division. On long division, we subtract in the middle. On synthetic division, we add. So -7 plus 10 is 3. Okay. All right, next up, we repeat the process. 3 times 2 is 6, and I add. Okay. So -6 plus 6, 0. This number that goes in this box right here is my remainder. And just like earlier when we did this problem, and we got a remainder of 0, we get a remainder of 0 here on this one. So that's looking pretty good. All right, last but not least, how am I going to write my answer? So here's how it worked at the beginning. This was x cubed, this was x squared, this was x, and this was my constant. What you do for your answer is you drop everything in power by 1. So now this will be x, this will be my constant, and this thing here will be my remainder. So what this means is this answer translated would be 5x plus, and here's my constant here, 3. And that's exactly what we got when we did this with a long division. Okay. So we said, hey, my answer should be 5x plus 3. And when I did this with synthetic division, I got 5x plus 3. Okay, so synthetic division, much quicker. We just write the number in the box. Okay, we write our coefficients, or we flip the sign and write the number in the box, whatever we're dividing by. Write our coefficients across the top. We drop this first number down, multiply by the number in the box, put that answer here, add in the middle, and then we just keep repeating the process. And you will get really, really fast with this, hopefully, because we're going to do some longer problems where you might have to do synthetic division 4, 5, or 6 times in order to find an answer. But the better you get at this and the quicker you get, the more this will flow. And I've realized I left off an R on this remainder. Okay, one more, and then I'll put a couple practice problems in the OneNote folder. All right, so let's try this one. Let's go 5x cubed plus 6x plus 8 divided by, and let's try x plus 2. Okay, and we're going to see, can we figure out what this is equal to? All right, first question, can I use synthetic division? This is linear. Okay, highest power is 1, and leading coefficient is 1. Okay, sorry, that got a little messy right there. But because of all that, I am allowed to use synthetic division. So let's go ahead and set it up. So I'm going to go ahead and put a box here. Remember, set this equal to 0. You can always do this work off to the side if you'd like. And then solve for x. I would get -2. So that's the number that I'm going to put in the box right here. Okay. All right. Be super, super, super careful on this one, because what you'll notice is this goes cubed, first power, constant. Okay. What we did here is we skipped x squared, which means we need to put a 0 in as a placeholder. So as I go across the top here, I'm going to put 5. I'm going to put a 0 in for x squared. Then I'm going to put a 6, and I'm going to put an 8. So if we're just thinking about how this lines up, and again, some students will write this at the top just to keep track of everything. This is x cubed, x squared, x, and constant. Okay, and then we can begin our process of long division. So let's go ahead and give this one a shot. So I'm going to start by, let's do this in green, bring our 5 down. Okay, 5 times negative 2 is negative 10. We're going to add in the middle here. 0 plus negative 10 is negative 10. Negative 10 times 2 times negative 2, sorry, negative 10 times negative 2 in the box is 20. 6 plus 20 is 26. 26 times negative 2 is negative 52. And then when I'm done here, 8 plus negative 52, or 8 minus 52, is negative 44. So on this one, we could say confidently that x plus 2 is not a factor of 5x cubed plus 6x plus 8, and we can confidently say that because we do not get a remainder of 0. However, that doesn't mean that we can't write our answer. So my answer here is going to be x squared, x constant, and then remember this number right here is the remainder. So how do we write this? Well, this is going to be 5x squared minus 10x plus 26, okay? Plus, and remember how this works is we do the remainder divided by the thing we divided by our divisor. Now, a lot of students are going to be not thinking they're going to write a negative 2 right here. That is incorrect because we did not divide by negative 2. The thing that we divided by here was x plus 2. Okay, so my final answer for this question would be this right here. So 5x cubed plus 6x plus 8 divided by x plus 2 gives me an answer of 5x squared minus 10x plus 26 plus my remainder, negative 44, divided by my divisor, which was x plus 2. All right, guys, I'll put some practice in the OneNote folder here. Hope that you guys are doing well. Miss y'all, and I'll talk to you later. Bye.